In this part of the video, we are going to look at public goods, which is the first market failure we are going to talk about in this chapter. But before understanding public goods, let's define what is a private good. And we have seen that the market system produces a wide range of private goods. These are the goods offered for sale in stores and shops and on the internet. Examples include automobiles, clothing, personal computers, household appliances, and sporting goods. Private goods are distinguished by rivalry and excludability. Rivalry in consumption means that when one person buys and consumes a product, it's not available for another person to buy and consume. Like if you buy an ice cream, this ice cream is available only for you. You eat it, and there is no leftover when you eat it. So it's not available for others. This is rival in consumption. The second one is excludability, and it means that sellers can keep people who do not pay for a product from obtaining its benefits. Only people who are willing and able to pay the market price for bottles of water can obtain these drinks and the benefits they confer. So example, think that you buy one Porsche, you can enjoy and use it because you pay the money, and nobody can else use and enjoy the benefits of buying a Porsche. Okay, that is excludability. Consumers fully express their personal demands for private goods in the market. If Adams likes bottled mineral water, that fact will be known by her desire to purchase the product. Other things equal, the higher the price of bottled water, the fewer bottles she will buy. So Adams' demand for bottled water will reflect an inverse relation between the price of bottled water and the quantity of it demanded. This is simply individual demand, as we described in chapter 3. The market demand, on the other hand, for a private good is the horizontal summation of the individual demand schedules. So suppose just two consumers comprise the market for bottled water. Okay, only two consumers, and the price is $1 per bottle. If Adams will purchase 3 bottles and Benson, another consumer, will buy 2, the market demand will reflect consumers' demand for 5 bottles of water at the $1 price. So similar summations of quantities demanded at other prices will generate the market demand schedule and the curve. It's very similar to individual demand, but it's the sum of all individuals asking for that good. Okay, it is just the quantities are different. It's a horizontal sum of all individual quantities demanded. Next, let's define what is a public good. Public goods have the opposite characteristics of private goods. Public goods are distinguished by non-rivalry and non-excludability. What is non-rivalry in consumption? It means that one person's consumption of a good does not preclude consumption of the good by others. Everyone can simultaneously obtain the benefit from a public good such as national defense, street lighting, a global positioning system, or environmental production. So you cannot exclude anybody from national defense as long as you provide it, okay? The second one is non-excludability. It means that there is no effective way of excluding individuals from the benefit of the good once it comes into existence. Once in place, you cannot exclude someone from benefiting from the national defense, street lighting, a global positioning system, or environmental protection. Okay? So as you see, you cannot exclude anybody, and non-rival in consumption means that your consumption will not decrease the amount that is available for others. So when you consume national defense, it's still the same amount that others can enjoy national defense too. So because of these two characteristics of the public goods, we have one main problem, which we call it free rider problem. Once a producer has provided a public good, everyone, including non-payers, can obtain the benefit. Because most people do not voluntarily pay for something that they can obtain for free, most people become free riders. These free riders like the public good and would be willing to pay for it if produce could somehow force them to pay, but non-excludability means that there's no way for producers to withhold the good from the free riders without also denying it to the few who do pay. As a result, free riding means that the willingness to pay of the free riders is not expressed in the market. from the viewpoint of producers, free riding reduces demand, right? Because you cannot exclude these people. People without paying can continue to consume the good. The more free riding, the less demand, and if all consumers free ride, demand will collapse all the way to zero. And the lower, even zero demand caused by free riding makes it virtually impossible for private firms to profitably provide public goods. With little or no demand, firms cannot effectively produce the good for revenues or profit. As a result, they will not produce public goods. So actually there is going to be a problem here because society has a benefit from the public good, but the private companies are not willing to produce it because there's either a very small demand or no demand at all. So here the problem is there are goods that brings marginal benefits that exceed the marginal cost, but they are not produced. Thus, if society wants a public good to be produced, it will have to direct government to provide it, right? Because the public good will still feature non-excludability, the government won't have any better luck preventing free riding or charging people for it. But because the government can finance the provision of the public good through the taxation of other things, the government does not have to worry about profitability. It can therefore provide a public good even when private firms cannot. Okay, that is the idea. So as you see, public goods are non-rival in consumption, non-excludable. So this creates a free riding problem. Since there are too many free riders, there is either zero demand or very less demand that private companies do not want to provide it. But we know that we need these goods because their marginal benefit is more than their marginal cost. So their society gets benefit from consuming of these goods. So the government can do it, and government, since doesn't need to have a profit motive, the government is going to collect taxes, which we will talk about it, and then finance this provision of the public goods. And then at the end we will have the public good plus we get the social benefit without the markets or the companies that are going to produce for us. So here is the demand for public goods. Demand for public goods is a little bit different than demand for private goods. It's somewhat unusual. Suppose, let's say there are two people, Adams and Bensons are the only two people in the society, and their marginal willingness to pay for a public good, national defense, in this figure, in this table you will see, is shown in columns 1 and 2 and columns 1 and 3. Economists might have discovered that these schedules through a survey asking hypothetical questions about how much each citizen was willing to pay for various types and amounts of public goods rather than go without them. Notice that these schedules in this table are price quantity schedules, implying that they are demand schedules. Rather than depicting demand in the usual way, the quantity of a product someone is willing to buy at each possible price, these schedules show the price someone is willing to pay for an extra unit at each possible quantity. That is, Adams is willing to pay $4 for the first unit of the public good and $3 for the second of the unit of the public good. And suppose the government produces 1 unit of this public good. If it's only 1 unit, as you realize in this from this table, only 1 unit, Adams' willingness to pay will be $4 and Benson's $5. Total benefit, collective benefit will be $9, okay? For the second unit of the public good, the collective price they are willing to pay $7, $3 for Adams and $4 for Benson. So it will bring us $7 of benefit. And third unit is going to be 5 and so on. By finding the collective willingness to pay for each additional unit, we can construct a collective demand schedule. As you see, it's different because we are looking at extra unit and how much you are willing to pay for the extra unit, okay? So by that way, we can determine the market demand for the public good. Here, we are not adding the quantities demanded at each possible price as we do when we do market demand for a private good. Note that we are summing Adams and Benson's willingness to pay curves vertically to drive the collective willingness to pay curve. Let me show it maybe using when I say that. Here is Adams' willingness to pay for the second unit is $3. For Benson's is $4. So you are summing these vertical distances, okay? Vertical distances, which are the prices. You are summing the prices to get the collective willingness to pay. Okay. So at $2, they are willing to pay $7. At 2 units, at 2 units of public good, they are willing to pay collectively $7. That is how we find out public demand curve. Okay, collective willingness to pay. We are not horizontally summing the quantities at each given prices. We are summing vertically the willingness to pay to get the collective willingness to pay curve. Okay, so what does it mean? For example, Adams is willing to pay $3 for the second unit of public good. What does that mean? It means that Adams expects to receive $3 of extra benefit or utility from that unit. And we know from our discussion of diminishing marginal utilities, as you know, any successive units of any good yield less and less added benefit. And this is also true for public goods, explaining the downward slope of willingness to pay curves for Adams and Benson's and society. And these curves, in a sense, are marginal benefit curves. Okay? So, in order to decide whether we need to build a public good, because it's very hard usually to calculate the marginal benefit or society's benefit for building a park highway, we will look at the cost-benefit analysis. What is cost-benefit analysis? It is actually very easy. In our example, cost-benefit analysis or marginal benefit, marginal cost analysis involves a comparison of marginal costs and marginal benefits of handling the public project. Let's look at an example. Suppose the federal government is contemplating a highway construction plan. Because the economy's resources are limited, any decision to use more resources in the public sector will mean fewer resources for the private sector. So there will be an opportunity cost as well as a benefit. The cost is the loss of satisfaction resulting from accompanying decline in the production of a private good. And the benefit is the extra satisfaction resulting from the output of more public goods. So the question is, should the needed resources be shifted from private to the public sector? The answer is yes, if the benefit from the extra public good exceeds the cost that result from having fewer private goods. And the answer is no if the cost of the foregone private good is greater than the benefit associated with the extra public goods. So cost and benefit analysis, however, can indicate more than whether a public program is worth doing. It can also help the government decide on the extent to which a project should be pursued. Real economic questions cannot usually be answered simply by yes or no, but rather involve questions such as how much or how little. So, let me clarify. Roads and highways can be run privately as excludability is possible with toll gates. However, the federal highway system is almost entirely non-exclusive because anyone with a car can get on and off most federal highways without restriction anytime they want. Federal highways therefore satisfy one characteristic of a public good, non-excludability. The other characteristic is non-rivalry is also satisfied by the fact that unless a highway is already extremely crowded, one person's driving on the highway does not preclude another person's driving on the highway. So as long as it's not jammed, there is no problem with rivalry. So it is non-rival in consumption. Thus, the federal highway system is effectively a public good. So this leads us to ask, should the federal government expand the federal highway system? If so, what is the proper size or scope for the overall project? Here you see the table. This table lists a series of increasingly ambitious and increasingly costly highway projects, widening existing two-lane highways, building new two-lane highways, building new four-lane highways, and building new six-lane highways. So as you see, A, B, C, D projects. Okay, widen existing highways is A, new two-lane highways is B, and C, new four-lane highways, and 6 is the new six-lane highways. And as you see, you can see total cost of project on column 2 and total benefit to the project. Marginal cost and marginal benefit is given, and net benefit also is given. Net benefit is the benefit that you get after you take out the cost from the total benefit. Okay, so the question is optimal size or scope for this project. We can look at the net benefit and we want to maximize net benefit. As you look at the net benefit column, you'll realize that the 5, which is project C, should be chosen. Okay, We can compare, on the other hand, the marginal cost and the marginal benefit relating to each plan. Also, this will answer the question. The guideline is well known to you from the previous discussion. Increase an activity, project, or output as long as the marginal benefit exceeds the marginal cost. As long as marginal benefit exceeds the marginal cost, stop the activity at or as close as possible to the point at which the marginal benefit equals to the marginal cost. Do not undertake a project for which marginal cost exceeds marginal benefit. From that perspective, Plan C has the best candidate because it has a marginal benefit 10 and marginal cost 8. So marginal benefit is higher than marginal cost. And we cannot take project D because it is marginal cost is higher than marginal benefit and it brings net benefit -2. Okay. So this marginal cost, marginal benefit rule actually tells us which plan provides the maximum excess of total benefits over total cost, or in other words, the plan that provides society with the maximum net benefit. Okay, so for that reason, we choose project C. And cost-benefit analysis shatters the myth that economy in government and reduced government spending are synonymous. Economy is concerned with using scarce resources efficiently. If the marginal cost of a proposed government program exceeds its marginal benefit, then the proposed public program should not be undertaken. Okay? That is how it works for the decision for undertaking a public good. Next topic is there are some goods that we can classify them as quasi-public goods. So government provides many goods that fit the economist's definition of a public good, but it also provides other goods and services that could be produced and delivered in such a way that exclusion would be possible. And these goods are called quasi-public goods like education, streets, highways, police and fire protection, libraries and museums, preventive medicine, and sewage disposal. They could all priced and provided by private firms through the market system, but because the benefits of these goods flow well beyond the benefit to individual buyers, these goods would be underproduced by the market system. Therefore, government often provides them to avoid the underallocation of resources that would otherwise occur. Okay. And how are resources reallocated from the production of private goods to the production of public and quasi-public goods? If the resources of the economy are fully employed, government must free up resources from the production of private goods and make them available for producing public and quasi-public goods. It does so by reducing private demand for them, and it does that by levying taxes on households and businesses, taking some of their income out of the circular flow. With lower incomes and hence less purchasing power, households and business must curtail their consumption and investment spending. As a result, the private demand for goods and services decline, as does the private demand for resources. So by diverting the purchasing power from private spenders to government, taxes remove resources from private use, so that this money can be spent for production of the public and quasi-public goods.